this video we'll be looking at 14.4 reflections. And so our essential question today will be, how do I reflect a figure? So before we can start reflecting a figure, we'll need a definition. A reflection is a transformation where the figure is flipped creating a mirror image. The line of reflection is the line an image is reflected over. So example 1, tell whether the images are reflections. Well, if you draw a line, can you just flip it over that line? Well, for A, no, there's no, if I draw a line down the middle, this doesn't just flip over it, so not a reflection. B looks like it's reflected, looks like it's a mirror image. I could say it's reflected right there, so yes. And the same could be said about C, where it looks like it's flipped over that, so we could say yes for C as well. So I'm looking at these reflected images. I have, let's look at example 2, part A. Reflect a triangle across the x-axis. So kind of like the easiest way to do this is to just count and then put your new points. So if I'm trying to get to the x-axis, I'm going to count 3 from B. 1, 2, 3. And since I'm reflecting, I'll count 3 again. 1, 2, 3. And there's my B prime. Same with A. I'll start with A, count how many it is to the x-axis, and then I'll count that same amount again. So I'll start here, and I go 1, 2, 3, 4, 5, 6, and now I'm going to go 6 more to find my reflection. 1, 2, 3, 4, 5, 6. And there's A prime. We'll do the same with C, counting 3, 1, 2, 3, and then I'll count 3 again, 1, 2, 3. So how many ever I count to get to that line of reflection, I'll count that again to find my new point. So let's connect these dots, and we've reflected our triangle over the x-axis. So what are the coordinates of the image? Well, point A was originally -5, -5, 6. And that went to -5, -6. Point B was -5, 3. And that went to -5, -3. And point C was -3, 3. And that went to -3, -3. Do you see any rule that kind of happened when we look at the coordinates? It's like a common theme from one point changing to a next. Well, we can say that the x, y was sent to, well, the x's stayed the same, so I can just put x, but the y's became their opposite, so I can put a negative y. So that's how we can see this as an algebraic kind of changing to show a reflection. So now let's reflect the triangle across the y-axis. I'm going to reflect it across the y-axis. I can use this same process where I just count till I get to the line of reflection and then count that same distance over. So let's start with A. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now I'm over here with my A double prime. And so B will count 1, 2, 3, 4, 5. So we'll count 5 again. 1, 2, 3, 4, 5. There's my B double prime. And then C will count 3. And then we'll count 3. And we'll have C double prime. Connect our dots. Now if I find my original points, negative 5 comma 6 for A was sent to 5 comma 6. And then negative 5 comma 3 was sent to 5 comma 3. 5 comma 3 for my B. And then my negative 3 comma 3 for my C point was sent to 3 comma 3. Now what's the theme with this transformation? Well, my y stayed the same. 6 stayed 6, 3 stayed 3, 3 stayed 3. But my x's now became their opposites. So we can say x comma y was sent to the opposite of x, comma, y stayed the same. Now, something I want to stress is this negative doesn't tell me that all these values will be negative numbers. Think of it as the opposite of x. So the opposite of negative 5 became positive 5. So it's not saying that I have negative values for x's. I have the opposite of my original values. The opposite of negative 5 is 5. The opposite of negative 5 is 5. The opposite of negative 3 is 3. Okay, so let's go ahead and flip to the back side of this. And on number 3, I'd like you to try this one on your own. You can pause right here. You'll draw the figure using these vertices. You'll reflect it across the y-axis, and then you'll write the coordinates of the new image. So if we tried this one on your own, let's take a look at it. First I'm going to draw my original figure. So I'll go negative 2, 5, A, negative 1, negative 1 for B. C was negative 4, 2, and D was negative 4, 4. So we have this trapezoid looking shape. And now we're reflecting it over the y-axis, A, B, C, and D. So I'm going to reflect it over the y-axis. So my A goes 2 and then 2, so there's A prime. D will go 4 and then 4. So there's D prime. C will go 4 and then 4, so there's C prime. And then B goes 1 and 1, and there's B prime. We connect our dots, and we'll have a mirroring trapezoid. So here are our rules. We reflected across the y-axis, so this rule will stay the same. Our x values became their opposites. Negative 2 became positive 2, and our y values stayed the same. So we'll have x comma y became the opposite of x comma y staying the same. Now our points are going to be A prime. Well, I can just use this idea where negative negative 2 comma 5, I can use this idea right here to quickly get my new points. Well, the opposite of negative 2 is 2, and y stays the same. B, negative 1 comma negative 1. Well, the opposite of negative 1 is 1, and the y stays the same. And C was negative 4 comma 2. And the opposite of negative 4 was 4, and then y stayed the same. And then D was negative 4 comma 4, and the same idea, the opposite of x would have been a positive 4, and our y stayed the same. Okay, in example 4, we're going to describe the image and give its algebraic representation. Well, this image has reflected over the x-axis, meaning our x values have all stayed the same as far as their sign's concerned, their values. X is 2 here, x is 2 here, but their y values have become the opposite. So the first thing we say in words is the figure is reflected over the x-axis. My algebraic would be xy is sent to, well, my x's stay the same, 2 stays 2, but my y's become their opposite. Positive 2 for y becomes negative 2 on our image, so our y's become their opposite. And that is how we can work with the transformation known as reflections. So thank you for watching this video, and I hope you have a great rest of your day.